We are now recording. Let's get the slide up on the slide. Current slide here. And what we were doing last time was graphing the tangent function. And we did example 1. Trying to see, here, I think this is, no?
No, we had graphed the sine and cosine functions.
Right, but didn't we start 4.6? Oh, no, I have 2 marks on the page. I'm sorry. I didn't erase one of the marks. We're right at the beginning. Right, this is right where we start here. Okay, 4.6, page 310. Okay, I think we did the little introductory thing, but here it says, and this is that first paragraph, almost. We know that the tangent function is odd. Do we really know that? Alpha minus x is always minus alpha of x. That's true for tangents, so they're always odd. So tangent of negative x is equal to negative tangent of x. Okay? Because whatever you do over here, you do the opposite over there. Okay? Now, consequently, the graph of y is equal to tangent x is symmetric with respect to the origin, meaning that what you see up here is the same down here with respect to the origin. You know from the identity function, and this is the ratio or the quotient identity, that tan x is equal to sine x over cosine x. Now, I don't know if you've done this before. Sine, you know, is an odd function. Cosine is an even function. Odd divided by even is just like negative divided by positive is negative. Okay, so that is also odd. So tangent is odd from that. But you also know that the tangent, therefore, is undefined everywhere that cosine is 0. Where is cosine 0? Okay. Where is cosine 0? That's right. Okay. Where on the x-axis? I mean, fine. 0 everywhere on the x-axis. Where is cosine 0? Cosine starts at 1, goes to 0 where? Boy, we know that 4.5 well, don't we?
Oh, at 1 and 0.
At what?
1 and 0.
Okay. All right. If you're picturing that on the unit circle, okay, cosine is your what? X or y?
It's x.
X. Cosine is x. And where is x 0? Not at here. Y 0 here. X is 0 up here.
Oh,
And down here.
1 and 0.
Say again?
Negative 1 and 0.
Okay. I'm not sure I know what you mean by that. When you say negative 1 and 0, I think of a point out here. X isn't 0 there, it's negative 1 there.
0, 1, 0.
Okay, 0, 1, and 0 minus 1. That's where x is 0, right? Now, what is your angle there? Up here and down there. Oh, yeah, pi halves and 3 halves pi. So it's your half pi's. So cosine is 0 at the half pi's. Two such values are positive pi halves and negative pi halves. Positive 1.5708 or something like that. Negative 1.5708 or something like that. Those are the places where your cosine is 0. Therefore, those are the places where tangent is undefined. And where tangent is undefined, you have a vertical asymptote. So that's usually a good place to start in graphing your tangent function. Put those vertical asymptotes in their place. The half pi's. Okay? So, here is when you go from x equals negative pi halves to positive pi halves is undefined at negative pi halves. When you go up to negative, now they do some other points in there. Remember this was point 1, negative 0.158, was it? It just was on there. 15708. So if you drop to negative 157, you're still at a very, very, very large negative number. Okay? So you're approaching negative infinity as you're going to there. So you're starting way low. And then I don't really worry with those two, but they throw them in there so you can see. And the laundry is here. Okay. So we got not quite half the class yet. We're getting closer. Okay, but here are the key points. Remember we had for sine and cosine, what were our key points? We did one period, say 0 to 2 pi, split that into 4 pieces. Okay? Well, what we're going to do with tangent is take one vertical asymptote at negative pi halves, another vertical asymptote at positive pi halves, and split that into 4 pieces. Well, that's a total of pi, right? From negative pi halves to pi halves is pi. Halfway in between that is 0, and halfway in between that is negative pi quarters and pi quarters. So those are the ones that I'm interested in. Negative pi halves, undefined vertical asymptote. Negative pi quarters, you're at -1. Why is that? Because tangent is sine over cosine, right? And negative pi quarters, sine is negative, cosine is positive, so that's going to be negative. But they're the same values, right? The pi quarters, root 2 over 2, right? Except the sine is negative, the cosine is positive. Root 2 over 2 over root 2 over 2 is 1. 1 being negative, 1 positive, that's going to be a -1. 0 is 0. Pi quarters is 1. Same reason. Pi quarters is sine and cosine of y is equal to x. So y over x is equal to 1. Okay? That's what tangent is, y over x. That's 1. And then go out to pi halves and you got another vertical asymptote because it's undefined there. Those are going to be our key points for tangent. Okay? So what we'll do is a vertical asymptote on the left, vertical asymptote on the right, at negative pi halves and pi halves, 0 in between, -1 between the vertical asymptote and 0, +1 between 0 and the next vertical asymptote. Those are going to be at the quarter points. Okay. Now, tangent increases without bound as x approaches pi halves to the left, and decreases without bound as x approaches -pi halves from the right. So it's going to negative infinity here, positive infinity there. So already we have a good idea of what it looks like. So here we have it. Negative pi halves, vertical asymptote, positive pi halves, vertical asymptote. In fact, every half pi, a vertical asymptote. Not your whole pies, your half pies. Okay? 0 in between each of those vertical asymptotes, +1 and -1, midway between the vertical asymptote and your 0, that should be pi quarters, -pi quarters and +pi quarters, 5 quarters pi, 7 quarters pi, -3 quarters pi, -5 quarters pi, all those are where they're plus or -1. Okay? And with those points, I wish they'd have put these in. They don't. I do. I use those as graphing aids. Okay? Now, here's something different about tangent and cotangent. Sine and cosine, what was your period? 2 pi. Secant and cosecant. They're reciprocals of sine and cosine. Cosine and sine, actually. So they're 2 pi. But tangent and cotangent, they repeat themselves every pi. And here's why. Remember the sine convention? positive there, negative there. It repeats every pi, not every 2 pi. So tangent and cotangent repeat, their period is every pi. And sure enough, you see that. Okay, it's 0 here, and 0 at pi, 0 at 2 pi, 0 at negative pi, and then 2 pi. It repeats every pi. The domain, all real numbers, x, except your half pi's. 1 half pi, 3 half pi, 5 half pi, negative 1 half pi, negative 3 half pi, and so on. So we express that with all x's as long as they're not equal to 1 half pi plus n pi. Not 2 n pi because the period is pi. The range, all real numbers. Another big difference between sines and cosine. Sine and cosine range, plus or minus 1. Tangent and cotangent, all real numbers. Okay? Vertical asymptotes, everywhere that x is not allowed, there's a vertical asymptote. Your half pies. This is for tangent only now. Symmetric about the origin, and the reason for that is an odd function. Okay? So, that's how the graph of tangent looks. It repeats itself every pi. Make sense? All right. Then let's do, okay, moreover. Let's see, here's some moreovers here, I think. Because the period of the tangent function is pi, vertical asymptotes also occur every pi, but they're on the half pi's, but they're still 1 pi apart. We're in plus n pi, where n is a whole number energy. Okay? Well, I'm sorry, an energy. Okay. Domain of the tangent function, set of all real numbers, domain. All real numbers except your half pi's, where they're not defined. The range is the set of all real numbers. Sketching the graph of y is equal to a tangent bx plus or minus c is similar to sketching the graphs of a sine bx minus c in that, okay, there are some similarities, but there's some big differences. Okay, first, sine, what was this range? Plus or minus 1, generally. Unless you have an a there, and that's in the amplitude. Then it goes up to plus a, down to minus a, whether the a is small or big or whatever. Tangent, however, all real numbers. So multiplying by an a on the tangent doesn't have an amplitude because it goes to infinity, no matter what, okay? But, remember that quarter pies? At the quarter pies, tangent is plus or minus 1. So there you'll be your plus or minus a. It's not an amplitude, but it does pertain to that quarter pi. Plus or minus a at your quarter pies. Okay? The b refers to the period. Now, what was the period for the sine function or cosine? 2 pi over b. Because 2 pi was our normal period. Guess what it is for tangent? Pi over b. So if you have a b there, don't divide it into 2 pi, divide it into pi. Okay? And then again, the other thing I do, I factor out the b and leave your x minus c over b. C over b is your phase shift. That's where your 0 would be. Shifted right or left, depending on what that is. So you still do the key points. The differences here is that you have an x and occasionally a y, one time a y and intercept, and then other than that you have asymptotes. You don't have max and min, you have asymptotes. Sine and cosine go to maximum plus 1 and plus a, minimum minus a. Those are your max and min. But in tangent, you have your asymptotes. Well, there aren't any maxes and mins. So, we do the same type thing, but we divide our period divided by 4. It's just the period is usually something to do with pi, not 2 pi. Okay, 2 consecutive vertical asymptotes can be found by solving these equations. And this, again, I found an awkward way to do it, but it certainly works. It's certainly fine. But if you find the b, the period, and offset, the phase shift, okay, find that. That gives you your 0 for a tangent, okay? And then do half a period to the left, half a period to the right. That's for your asymptote line. So either way you do it, it works the same thing here. The midpoint between the two consecutive vertical asymptotes is the x-intercept. That's your the period of the function y is equal to a tangent bx plus c is the distance between the consecutive vertical asymptotes. In other words, pi over b. You don't need to do the other thing, just remember it's pi over b. They set up these equations and go from there. I find it easier to do it just like we did for sine and cosine. Okay. Only thing to remember, A is not there aren't any amplitudes in sine, tangents and cotangents. They go to infinity. But that is the place where your quarter pi's will be, at the plus or minus a's. Okay. The amplitude of a tangent function is not defined. Don't worry with that. But the a is still important because that's where your quarter pi's are. So that's the only difference here. That's where your quarter pi's are at plus or minus a. After plotting the asymptotes and the x-intercept, plot a few additional points. Well, what additional points are those? Your quarter pi's. Okay? Do your quarter pi's at plus a and minus a, and you've got it 9. Finally, sketch 1 or 2 additional cycles to the left and to the right, and you've got it. Again, their approach is right, but it's just a little awkward, it seems like to me. So let's do this one. Let's sketch the graph of y is equal to tangent pi over 2. Okay, let me get my pen set up dark here. All right. I like to start just like we did before. The book probably doesn't. What's your A here? 1. Okay. Now, for sine and cosine, the A refers to amplitude. Okay. In tangent and cotangent, the A refers to your quarter pi's. Okay, the values of the quarter pi. So they're going to be plus or minus 1. Okay? So don't throw it away. It's still useful. What's your B here? Say again? Okay, the B is 1/2. That's the coefficient of the x, right? The period then is pi over b, which would be pi over 1/2, which would be 2 pi. So we're back at a 2 pi period. Sorry about that, but it's fine. Okay. And actually, when I was saying pi quarters, I should have been saying quarter periods, not quarter pi's, but quarter periods. Because what are we going to do once we found that period? Divide by 4. And when you divide by 4, what does that give you? Pi halves. Those are going to be the key points. Okay? So here's a 0, pi halves, pi, 3 halves pi. I'll just tick them off here. Okay? And up here I will do plus 1, minus 1. Doesn't matter where we go from there, but okay. Now, there's no phase shift. Your C is 0, so there's no phase shift. All right? So we know we're starting at the origin. Tangent, because it's sine over cosine, and sine is 0 at 0, tangent's got to be 0 at 0. Okay? Now, each one of these, remember I said was pi halves. So this is pi, this is 2 pi, this is 3 pi, this is 4 pi, and so on. Minus pi halves, minus pi, minus 2 pi, minus 3 pi, minus 4 pi, and so on, and so on. And we'll call this 1, minus 1, 2, minus 2, minus 3, 2, 3, 4. Not that we need those, but we've got them. Okay. Now, we got our offset is 0, phase shift is 0, so we're starting at 0, 0. That's where tangent usually begins. Now, half of a period to the left, and a period was 2 pi, so half a period to the left is a vertical asymptote. That's at pi, and at negative pi. These are your half periods. Okay, and because they're vertical asymptotes, well, I thought I was getting red. Okay, I did get it that time. Vertical asymptote there. There. This is because your period is now 2 pi, not pi. They're exactly okay. So there's your vertical asymptotes. Normally they'd be at the half pi's, but here because your period is 2 pi, they're at pi's. Okay. The odd pi's. Okay. Now, what the A tells you is where you are at the quarter periods. Okay? The quarter periods, let me go back to my dark color. Quarter period, which now is pi halves, that's at plus 1 here, minus 1 there. Minus 1 here, plus 1 here. Minus 1 here, plus 1 here. Oh, and on the even pi's, you are at 0 again. Exactly halfway in between your vertical asymptotes, and then you're at plus 1 here, minus 1 here, plus 1 here, minus 1 here. Okay? So basically this is doing like this, like that, like that, like that, like that, and so on. There's your graph of y is equal to tangent x over 2. Looks just like the tangent function, except it's a horizontal stretch. Remember, if your coefficient is 1/2, something between 0 and 1 is a stretch. So you stretched it, you doubled it. Okay? So before, your vertical asymptotes would have been on the half pi's with the periods on the pi. Now your periods are the 2 pi, and your vertical asymptotes are at the odd pi's. Okay? Does that make sense? No? Okay, which? Okay. Well, first thing I do is look for my A, even though we don't have an amplitude with tangent and cotangent. We do not. In fact, secant and cosecant, we don't have amplitudes either. But A is still important. We'll get to that later. The A is 1. What that's going to do is tell me where we're going to be on the quarter periods, here and here. Minus 1 plus 1. Okay? Minus 1 down here, plus 1 up there. That's what my A is going to tell me. The B is the coefficient of the x, and that's 1/2. Just like before, the period is a normal period divided by b. For tangent, the normal period is pi. Divide that by b, which in this case was 1/2. That flips it over and makes it 2 pi. So now your period is 2 pi because that's a horizontal stretch. Okay? What's that? Okay. So once you got the period to be 2 pi, divide that into the quarters. Okay, just like we did before. And that comes out pi halves, a lot like it did with sine and cosine, because we had this b equal 1/2 in here. Okay? So that's why we're back to 2 pi's again. So now we know that tangent starts at 0, at the origin at 0. You have no phase shift, so it stays at 0. half a pi from there, half a period from there, period being 2 pi, so half a period is pi, you have a vertical asymptote on either side. Okay? Draw those vertical asymptotes in. Draw your intercept exactly in between your vertical asymptotes. Okay? And then once you got those in place, halfway between them, which is your quarter period, in this case pi halves, you're at plus 1 here, minus 1 there. Plus 1 here, minus 1 there. Plus 1 there, minus 1. Just go down the way like that. Okay? And then connect the dots. Don't ever cross or touch a vertical asymptote. Stay in between the vertical asymptotes, and you've got your little wavy tangent lines everywhere. Okay? Make sense? Kinda, a little bit. That's my rendition of it. The book does it a slightly different way, which is perfectly legitimate, but a bit weird in my mind. Not Jasmine, she just came in. It's not weird at all. Okay. And here we have my middle of the class row here, right down the line. Okay. And what I'm going to do is erase this ink, but yeah.
That first dot is above that 4, negative 4.
Right here?
Yeah, go above that. That first dot up there at the top. Yeah, right there. What, that is on the 1?
That's on your quarter period, okay, which is your half pies, or your quarter periods here, okay? And that's going to be in between minus 3 pi, minus 4 pi, minus 3.5 pi. And that's where you're going to be plus 1 there, minus 1 down here. Because if your quarter periods, that's where your plus or minus A. And your A here happens to be 1. They don't mention that in the book. Why not? It's a really easy thing to use and to help you do in your graphs. No reason not to. All right. Now, okay, to erase the ink. All right, we'll see them draw it. Now, they go through a different way of doing it, which is perfectly correct. There's nothing wrong with it. Just to me, it's awkward. Okay? And how they start is by doing the x over 2, which is what your argument here is, minus pi halves for your vertical asymptote on the left and minus pi halves for your vertical asymptote on the right. Perfectly fine way of doing it, but to me, just a bit awkward. But then when you do this, you see you can multiply both sides of the equation by 2, and that gives you x equal minus pi or plus pi. That's where your vertical asymptotes are. Okay? 2 consecutive vertical asymptotes occur at minus pi and pi. That means the period between them is 2 pi, because the difference between minus pi and pi is 2 pi. So that's how they go about getting their period. If you just use the same thing we did before, pi over 1/2, 2 pi, you just get it so much easier that way than if you go through this way again. And they still haven't told you that's what it is, but that's what it is. Okay? But if you like this way better, go for it. It's fine. Perfectly fine. Okay? Now, between those two asymptotes, that was at minus pi and pi, you have, those are 2 of your 5 points. Okay? Exactly halfway in between there is a 0. And then to the right of the 0 and halfway here, that's at your quarter period, pi halves in this case, and they didn't do that either. That's at your plus 1 or plus A and minus A on this side. Okay? So that's where I use the A's. They don't ever mention them, but that's where you should mention them. That's minus A and plus A at your quarter periods. Undefined at the vertical asymptotes, plus or minus A at a quarter of a period, 0 at the center of the period. Okay? That's it. And you do those for every period, connect the dots, you've got your tangent function. Okay? And here's how they did it. Same way we did. In fact, they even show the dots in there. They don't tell you this is minus A and that's plus A, but it should be It's on the quarter period. One period is between here and here. Okay, so a quarter period is each of those. And vertical asymptote here to here. Intercept in between, minus A plus A. And you just repeat that process every period. Pretty straightforward, pretty easy to do. Just remember there is no amplitude for tangent and cotangent, nor is there for secant and cosecant either, only sine and cosine. But the A's are important still. That gives you your plus or minus values at your quarter periods. Okay. That's for tangent. Okay. Can I move on? Okay. Now, before we get the graph of cotangent function, let's do example 2. Sketch the graph of y is equal to -3 tangent of x over 4. Okay? Where would you begin? Say again? Did you say A? Okay, yeah. What is your A? -3. Now that, for tangent and cotangent, and secant and cosecant, has nothing to do with amplitude. But it does have meaning. That's going to be the values at your quarter periods. Okay? Values at the periods over 4. Quarter periods. What next you look for? B. And what's your B in this case? Now x over 4, 1 over 4. X is your variable. The coefficient of that variable, that's your, so 1 over 4. And what is B used to find? Period. And what is the period? Pi, because this is tangent or cotangent, you use pi. Sine, cosine, secant, cosecant, use 2 pi. Tangent and cotangent, you pi. Over your B, which is 1/4. So that would be over 1/4. And what would that be? 4 pi. What do you do with that period? Divide by 4. And your quarter periods are going, your quarter periods are going to be pi. So that's what I'm going to plot on my x-axis, or my quarter periods, which are pi's. So there's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, -1 pi, 2, 3, 4, 5, 6, 7, 8. And we'll go up 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, blah, blah, blah. Okay. Now, what's your C? What's your C? Don't see a C. So therefore it's 0. That means your phase shift is 0. That means we're going to start at the origin where we expect to start with tangent. So this is the tangent function. Okay? So we know we'll be here. Where is our vertical asymptote? Half a period to the right and half a period to the left. What's our period? 4 pi. No, your quarter period. Okay, you can do it either way you want to. Your quarter period is pi. So, I didn't write them in. Pi, 2 pi, 3 pi. I said them when I was doing them, but 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Boy, that sounds hungry. Okay, -pi, -2 pi. Okay, just a second. Let me get these filled in. Okay, now, your vertical asymptotes are always 1 period apart. Your 1 period here was 4 pi. So that means if you got the origin here, and you know you do, no offset, be half a pi this way and half a pi that way. Or 2 quarter pies this way. Whichever way you want to look at it. Half a period or 2 quarter periods. Either way is going to give it to you. And that's going to be, let me get my red back up here again. Okay. That's going to be at 2 pi and at minus 2 pi. And remember, they're 1 period apart, and 1 period is 4 pi, so that's going to be at 6 pi and minus 6 pi. Yuck. Those are your vertical asymptotes. Okay? Getting my dark color back. Then your intercepts are going to be halfway in between each of those. Okay? Those are your intercepts. Okay. Now, your quarter period, which is pies. Okay? Your quarter period is going to be your plus or minus A, right? And what was your original A? -3. So to the right you go -3. To the left you go opposite of -3, which would be a +3. That's what that minus does for you. This minus right here is going to flip it over the x-axis, remember? Okay? So you're going to go from +3 to -3. +3, can't get the -3 there. Going back this way, -3, +3. -3. Okay? So this is going to be coming down like this. This is coming down from the vertical asymptote through the A and down to minus A. Okay. That's what this function looks like. -3, that -3 is a vertical stretch. So rather than be at plus or minus 1 now, they're at minus or plus 3 now, okay? Because that's a vertical stretch. The minus sign flips them over. So what would have been going uphill is now going downhill, okay? That's what the minus sign does. The 3 stretches it. The pi fourth is a horizontal stretch, or x fourth, 1/4 x is a horizontal stretch, multiplying a period, which would have been pi, by 4, which means it's 4 pi. So your vertical asymptotes are going to be half a period, which is 2 pi to the left, 2 pi to the right, and then every 4 pi from there on. Okay. Does that kind of make sense? All sorts of things going on here. Reflection across the x-axis, vertical stretch, horizontal stretch. Okay? No phase shift. Or that would be a horizontal shift. No vertical shift either. See, they're not even mentioning D's here. If you had a D in here, that would then raise up the equilibrium point or lower it, wherever that would be. They're not doing any of those yet. I don't think they'll do any, but they haven't yet. And if you look in the book, you'll see we're fairly close to that. Oh, no, we're not. Their example 2 in the book is different from the example 2. Where did I get this? Oh, I'm sorry. I did the checkpoint. I looked up there. Sorry about that. Yeah, exactly. Sorry about this. Okay. Yeah, that's me. I'm always really spontaneous. That's my wife. Yeah. I'm sorry. I miscopied the problem. I got the -3 from the example 2 and the pi x over 4 from the checkpoint. Sorry about that. Let's go back. You want to do it? No? Okay. I'll just tell you let me just get some of this out of the way and just point out the things that will be different. Okay. -3 tangent of 2x. That's what it should have been. Okay? The a was still minus 3, same as before. Now the b is 2. The period is pi over 2, which is pi halves. Okay? Is pi over 2, which is pi halves. You divide that by 4 and you get pi eighths. So that would be where my tick marks would be. This would be pi eighths, pi fourths, 3/8 pi, pi halves. Okay, and on like that. It just changes the scale of things. And so therefore your quarter of a period would be pi eighths, and that would be where your, and this would be minus pi eighths, minus pi fourths, 3/8 pi, pi hat, minus pi halves, minus 5/8 pi, and on like that. And this would be minus 3/2 pi. Okay. So it would just go on like that. So everything is very similar except the period. I messed up the period because I put the wrong coefficient in there.
So what would have been, like for your problem, negative 3 tangent 1?
Say that again.
What would have been the problem that you wrote for this?
This was negative 3 tangent 2x. That's the one that's in the book.
No, what's the one you
Oh, the one I was doing was negative 3 tangent x over 4. I took the negative 3 from example 2 and the tangent x over 4 from the checkpoint above it. I just went to the wrong direction. But you see, you can do any of these anyway. Yeah, you can be spontaneous. Okay. So, all that did was change the x scale. Okay. We were at pi's, now we're at pi eighths. Okay. And just deal with that then. All right, sorry about that. All right, that was example 2. Now I think we're ready for cosine function. All right, cotangent function. All right. Now cotangent function is now cosine over sine. So how does this differ from tangent? Tangent being sine over cosine. It's what? Okay, flip them. So what does that change in our graphs? In some senses, maybe, but more importantly, the vertical asymptote. Because remember, for tangent is where cosine was 0. Those are your vertical asymptotes. With cotangent, it's where sine is 0. And where is sine 0? The what?
On the x-axis.
I can't do it.
On the x-axis.
Okay. All right. The x-axis is where the y is 0. I'm asking where sine, the function sine is 0. Okay. Sine starts at 0, 0, so that's one place. Then it goes up and comes down back to 0 again. Go down and back up to 0 again. Where is it 0? Here's a hint. Cosines were 0 at the half pies. Sines are zeros at the whole pies. Exactly. I like whole pies better than half pies anyway, don't I? Okay, never mind. Okay, so these are 0 at the whole pies. So therefore, your cotangent, you know exactly where those vertical asymptotes are going to be at the whole pies. In pi. Where n is 0, 1, 2, 3, 4, 5, go. That's where that is. So draw in those vertical asymptotes immediately. Vertical asymptotes when sine x is 0, which occurs at n pi. Where n is any integer. Okay. The graph of the cotangent function is shown below. This is the regular parent cotangent function. Vertical asymptote is 0 pi, 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi, negative 3 pi. Vertical asymptote at every pi. Okay. Now here's the thing to remember about cotangent. Okay. Those are the vertical asymptote. That means the function either is positive up here or negative here. But in the first quadrant, which is 0 to pi halves, everything is positive. So therefore, you have to be starting from positive infinity coming down. So this is always decreasing, whereas the tangent function was increasing. Make sense? And since they're reciprocals of each other, that makes sense too. Okay? So your zeros here, your vertical asymptotes are at the whole pies. Your zeros are then going to be on the half pies. Okay? And then your quarter pies are going to be plus or minus a's. We haven't said what a is yet, but when a is there, this will be at plus a minus a, plus a minus a. Exactly the reverse, tangent was at minus a plus a minus a plus a, because it was an increasing function. This is a decreasing function, which is plus a minus a plus a minus a. Okay. The C is your phase shift, or deals with the phase shift. And then just like tangent, the period is pi. The only two of your 6 trig functions with a period of pi, tangent and cotangent. The other 4 have periods of 2 pi, at least the base period. Domains, all x's except your n pi's, that's where your vertical asymptotes are, at the n pi's. The range, all real numbers. Okay? The symmetric, again, about the origin. It's an odd function too, just like, because it's reciprocal of an odd function. So what's going on here, the opposite's going on here. It's going here, the opposite's going on there. Odd functions. They do their little bx minus c equals 0 and pi. They do it that way. You can do it that way. I think it's far easier to analyze it just like we did before. Remember, the a is not an amplitude. It's where your quarter periods are, plus or minus a. Whereas sine and cosine, that's your amplitude, and your max and min are plus or minus a. Your tangent and cotangent, that's where your quarter periods are at plus or minus a. Okay. They don't ever say that, but that's the case, so might as well use it. So let's do this one. Let's sketch this graph. Y is equal to 2 cotangent x over 3. What's the first thing you look for here? And what is your A? 2. And for tangent and cotangent, that refers to your quarter periods. Those are going to be the values at quarter period plus or minus 2. Okay? Next, B is what? 1/3, which implies what? The period is pi over b, which is pi over 1/3, which is 3 pi. And then what do we do with that period? Divide it by 4, so we'll do, our tick marks are going to be at 3/4 pi. A little awkward, but okay. Okay? And your C, of course, is, so far they haven't given you a C yet. They're saving those for the test, okay? Now, no, I get them out of the test bank. Okay. So, we set up our tick marks at the 3/4 pi. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7, 8. Positive 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. Okay. So each tick mark is 3 pi over 4. So this will be 6 pi over 4, which is 3 pi over 2. This will be 9 pi over 4. And this will be 12 pi over 4, which is 3 pi. So 1, 2, 3, 4, 1, 2, 3, 4. This will be 6 pi out here. Minus 3 pi over 4, minus 3 pi over 2 minus 9 pi over 4 minus 3 pi. 1, 2, 3, 4 minus 6 pi. All right, we'll do 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Notice I don't scale evenly at all, but x's and y's don't have to be on the same scale. Just get the general shape, okay? So that's what we get from our quarter period, okay? The next question to ask, where are your vertical asymptotes? For a cotangent function, where are your vertical asymptotes? Where are your vertical asymptotes? We would have been saying whole pies. Now we say whole periods. So cotangent, if there's no phase shift, that first one is the y-axis. Remember that, okay? And then your period is 3 pi, remember? And half of that would be 3/2 pi. So here's going to be the next one. No, sorry. No, I'm sorry. Blew that one. Remember, your vertical asymptotes are 1 period apart. Okay. Yuck. And your period is 3 pi. So this will be at 3 pi and at 6 pi. And at negative 3 pi and at negative 6 pi. Because your vertical asymptotes are 1 period apart, and the period is 3 pi. And you know for cotangent, it starts at the y-axis. Unless there's a phase shift. There's a phase shift, you start wherever the phase shift is. But this one doesn't have a phase shift, so you start at the y-axis. Now what's halfway between each vertical asymptote? It's halfway between each vertical asymptote? A 0. A 0. A 0. And a 0. My wife has a 0 up, but no, this is a 0. Never mind. All right. Now, where do you go at your quarter periods? 2, plus or minus 2. And in the first quadrant, everything's positive, so this is going to be at plus 2, so this must be down here at minus 2. This up here at plus 2, this one down here at minus 2. This one down here at minus 2, this one up here at plus 2. This one down here at minus 2, this one up here at plus 2. Okay? And they're approaching the vertical asymptotes, can't touch them, but they can approach them. And it keeps on going like that, okay? Okay, something like that. See how those work? Again, don't reinvent the wheel. Use your A, B, C, D. Use those. The A for sine and cosine refers to amplitude. For tangent and cotangent refers to your quarter periods. Okay? The B refers to the period. Okay? Remember, for sine and cosine, and therefore secant and cosecant, we haven't gotten to yet, that's always 2 pi over b. For your tangent and cotangent is pi over b. So that gives you your period. Once you've got your period, then take your quarter periods, because that's where your tick marks are going to be. So that gives you your tick marks for your x-axis. Basically, your A kind of gives you your tick marks for your y-axis. Okay? You want to make sure you get a plus or minus 2 in there, because those are going to be some key points there. Okay? Then you can have the others above and below that. No problem. Okay. Once you've gotten your quarter periods ticked off there. That means you got them mad at you, okay? You know that cotangent with no phase shift is going to start on the y-axis. Tangent is going to start at 0 on the y-axis. And then its vertical asymptote is going to be half a period away. For the cotangent, if there's no vertical shift, horizontal shift, a phase shift, it's going to start on the y-axis, and then every period away you're going to get another vertical asymptote because they're one period apart. Okay? So plot that first one in, and then plot one every period apart, both directions. Halfway in between your vertical asymptotes, you always have a 0. And halfway between the zeros and the vertical asymptote, you have your quarter periods, which is your plus A and minus A. And they go like this because here's what I remember. First quadrant, always positive. So make sure you got all that on positive. Unless, of course, that had been a minus 2, and then it flips it over. Okay. Does that make sense? Somewhatly, huh? All right, that's how I did it. Let's see how they did it. And to me, their way is more awkward, but if you like their way, go for their way. It works. Okay, they start with the argument of the cotangent, x over 3. And they say they know the first two vertical asymptotes are going to be where that's equal to 0 and where that's equal to pi, because the periods of pi. And then from there, they continue. And the first one will give you x equals 0. The second will give you x equals 3 pi. Those are exactly our first two vertical asymptotes, 0 and 3 pi. Okay? Then halfway in between those, you have your zeros. So that would be 0 vertical asymptote and 3 pi vertical asymptote. Halfway in between that, 3 half pi, a 0. And halfway in between those, 3/4 pi and 9/4 pi. In other words, 1/4 pi, 1/4 period away, you're going to have your plus 2 and your minus 2. And cotangent starts plus minus, tangent does minus plus. Just remember that, because in the first quarter period, everything's positive unless you have a negative coefficient A. Make sense? Here's how it looks. It's just a lot like ours. I don't know why, but I guess they don't have the graphics to do it. But I would have put, and I did put, a vertical asymptote on the y-axis too. But I think they can only draw one vertical line into place, so they can't do two. 0, 3 pi, 6 pi, negative 3 pi, negative 6 pi. Halfway in between is 3 half pi, is 0. Halfway in between that is 3/4 pi, plus 2. And 3/4 past that is 3/4 pi past that is minus 2. Those are your key points. Why they don't tell you those are at plus or minus A, I don't know. But they always are. So why not use it? Good deal. Any questions on that? That was example 3. Now we go to the graph of the reciprocal functions. Well, guess what? Cotangent was a reciprocal function. We already did that. They mean reciprocal for sine and cosine, which of course are what? Secant and cosecant, but actually in the reverse order, cosecant and secant. Okay. Now, you would think these would be getting more difficult. And they are more complicated looking graphs, but they're actually much easier to draw. Okay? And here's why. You can obtain the graphs of the two remaining trig functions from the graphs of sine and cosine. And we know how to do sine and cosine, right? So do your sine and cosine first, and then we'll use the principle that they are reciprocals of each other. Okay? That cosecant is reciprocal of sine, and secant is reciprocal of cosine. So for instance, given a value for x, the y-coordinate for secant x is reciprocal of the y-coordinate for cosine x. Okay? You're not going to do that on every one, but it's true. Of course, when cosine x is equal to 0, what's the reciprocal of 0? undefined, meaning vertical asymptote. So everywhere cosine is 0, again, secant has a vertical asymptote. Same places tangent has vertical asymptote. Exactly the same. So the first thing I plot when I'm trying to do a secant or cosecant, I plot a sine or a cosine, whichever is appropriate. And then everywhere that sine or cosine is 0, draw a vertical asymptote right there, because you know the reciprocal can exist there. Okay, so that's the first thing. Draw the appropriate sine or cosine. And everywhere you have a 0, do a vertical asymptote. Okay. And near those is the secant is similar to tangent because they're in the same places. We'll get there. So in other words, the graph of tangent, which is sine over cosine, and secant, which is 1 over cosine, they have the same vertical asymptote. So since you know where they are, put them in their place. But you see it's even easier here. Go and plot the cosine first. Everywhere it crosses the x-axis, draw a vertical asymptote. Okay? So for cosine, that would be at your half pi's. For cosecant, that would be 1 over sine. Those would be the whole pi. Okay. So vertical asymptote wherever either sine or cosine is equal to 0. Okay. Are we running out of time? Oh, not yet. We got 2 minutes. Okay. To sketch the graph of secant or cosecant, you should first make a scratch. I've already said it, of the sine or the cosine, whichever is appropriate. So if you were trying to do cosecant, first sketch the sine. Do it on that same thing. Then take reciprocals, and it's actually easier than that. Okay? And we'll pick up and go from there next time. Okay? So we will be starting right here next time. Let's see. I think we got some homework exercises, don't we? Yay! All right. I would do all of 9 through 14. They only have the answers for the odds in the back, but I would do them all. Do all of 9 through 14, but check your answers 9 through 13. Odds. Okay? Then you can do 15 or 17. 27, 31, 39, 43. There they have a phase shift. I knew they'd save them for the homework, okay? Try 47. Okay, we'll do it. Say again? You ready? Good deal. Thank you. Thank you much.